Section 10.2.3 is titled Chords and Angles, and we're going to answer the question, what more can I learn about circles? Be sure that you read page 17 first. Question 74 says, what if it is a semicircle? What is the measure of an angle when it is inscribed in a semicircle, an arc with a measure of 180 degrees? Consider this as you answer the questions below. In the diagram at right, if the measure of arc QR is 180 degrees, then what is the measure of angle P and why? It would be 90 degrees because the inscribed angle is always half of the intercepted arc. So if you take 180 and divide it by 2, you're going to get 90 degrees. Part B says if you drew QR, what would be special about it and why? So if we connect the Q to the R over here, it would be a diameter because it connects points 180 degrees apart on that circle. C says if point P has moved to a different location on the circle, would the measure of angle QPR change? Sketch circles with point P in 3 different locations and justify your answer. So assuming that point P does not coincide with point R or Q, then the measure of QPR will always be 90 degrees because it is inscribed in a circle. So if point P moves right here, it's still half of 180. If it's moved over here, it's still half of 180. If it's moved over here, it's still half of 180. Part D says, in the diagram at right, UV is a diameter. What kind of triangle is triangle UVT? Why? If TU is 6 and TV is 8 units, what is the length of the radius of the circle? What is its area? So it must be a right triangle because angle T is inscribed in a semicircle and hence it is a right angle. This is 180 degrees. Half would make that 90. And then we can use the Pythagorean theorem to solve for that hypotenuse over there. So we're going to say that C squared equals A squared plus B squared. Plug in the 6 and the 8, the 2 legs. Square both of them, add them together, and then take the square root, which gives us a diameter of 10. But the question was, what is the radius? So you take half of it. So the radius is 5. And then they want the area of that triangle. So, what is the area of the circle? So we're going to do pi r squared. So pi times the radius of 5 squared. 5 squared is 25, so it's 25 pi units squared. Number 75. A polygon is inscribed in a circle when each of its vertices lies on the circle. How are the angles of a quadrilateral inscribed in a circle related? Consider this as you answer the questions below. For polygon ABCD inscribed in the circle at right, solve for x and explain how you found your answer. Okay? So if we know that angle C right here is 100 degrees, we want to get the measure of arc BAD. So BAD goes all the way from here. Well, that angle is inscribed in that arc, and it must be half of that arc over here. So half of 200 is 100, or doubling 100 will give you 200. Then we want to know what is the measure of BCD. BCD is going to be 160. This is 200. We subtract that from 360, and 360 minus 200 is 160, which is going to make its angle, inscribed angle, 80, because half of 160 is 80. Alejandra notices something. I think that the opposite angles of a quadrilateral inscribed in a circle are always supplementary. Is she correct? Okay, so yes, she is correct, because opposite angles are part of the whole circle, which is 360. So half of 360 is going to be 180, so half and half of 360 would each be 180. Go ahead and turn over to the top of page 16. Timothy asks, what if two chords intersect? What if two chords intersect inside a circle? Can triangles help you learn something about these chords? Look at this diagram at right, in which chords A, B, and C, D intersect at point E. Timothy decided to create two triangles, triangle BED and triangle CEA. Add segment BD and CA to your diagram. So you're just going to draw them in, connecting them and making two triangles. Compare angle B and angle C. Which is larger? How can you tell? Likewise, compare angle D and angle A. Angle B and angle C are going to be congruent because they intercept this same arc over here. We'll call it arc DA. And then we want to compare angle D and A. We're going to say that they're congruent because they share this arc over here, arc BC. So if they share the same arc, their angle measure is going to be the same measure. Question C says, how are triangle BED and triangle CEA related? They're going to be similar by the angle-angle postulate because they both have congruent angles, two pairs of congruent angles. They're going to be similar. So if DE is 8 and AE is 4 and EB is 6, what is the measure going to be of EC? So we're going to set up our proportion. We're going to put DE to AE, set it equal to EB to the missing side. Then we're going to do the cross product, which gets us 24 this way, divided by 8, which means that EC is 3 units. Question 77 says, in lesson 10.2.1, you learned that a chord is a line segment that has its endpoints on a circle. What geometric tools do you have that can help calculate the length of a chord? Explore this question below. Examine the diagram of chord LM in circle P at right. If the radius is 6 units, and if LM is 150 degrees, what is the measure? What is the measure of LM? Be ready to share your method with the class. Okay, so if it's a total of 150 degrees, that would be a central angle. So we're going to divide it by 2 to get the 75 right there. Since we can make a right triangle in there because it's perpendicular, we're going to set the hypotenuse, which is a radius, equal to 6. We want to solve for this side, which is the opposite of that angle 75. So opposite and hypotenuse, we should use sine. We're going to say the sine of 75 is equal to its opposite of x over its hypotenuse of 6. We're going to do the cross product after making our proportion. Punch it in the calculator, and we're going to get roughly 5.79, which would give you from here to here. Then we need to double it to get the whole way across, so roughly 11.59. What if you know the length of a chord? How can you use that information to reverse the process and calculate the measure of the arc? Draw a diagram of a circle with a radius of 5 units and a chord AB with a length of 6 units. What is the measure of arc AB? This time, because we want the angle in there, we're going to use the inverse trig. So in this case, it's, again, opposite and hypotenuse. So we're going to use sine, but it's inverse. Opposite is 3, hypotenuse is 5. Punch it in the calculator. It's going to give you approximately 36.9 degrees for that angle, but we want the angle of the whole thing, so we need to double it to get 73.7. And again, make sure you read the math note page on page 17.